Of the 50,000 known species of spiders, jumping spiders make up about 6,000 species. When thinking about animal vision, there's usually a simple rule. Bigger eyes means finer detail. This is a chart that shows it as a clear trend. As eye size increases, visual acuity increases too. A simple upward line. Most insects sit low on that line, but jumping spiders break this pattern. They sit far above the curve, seeing with a level of detail that their tiny eyes shouldn't allow. They're better than rats, they're better than most fish. As good as an elephant. How is this possible? Jumping spiders possess several pairs of eyes. There are the huge ones at the front, and then there are 3 pairs cascading down their head. Do these eyes provide redundancy, or do they all do different things? Each set of these secondary eyes detects motion in a specific part of a nearly 360-degree visual field that wraps around the spider like a dome. Secondary eyes detect motion, and the principal eyes analyze it.
The secondary eyes giving them the scene, essentially in black and white, and then these principal eyes moving around, filling it in with color and pattern, any place that they might be interested in looking. Secondary eyes are what we would call simple eyes. You can also call them camera eyes. The idea there is that they have a lens, often with a little bit of a clear space between the lens and the retina, but the retina is a sheet of photoreceptive cells.
But the principal eyes are built very differently from that, and they are widely considered the most sophisticated eyes relative to their size in the animal kingdom. These eyes are not round, but long and tubular, basically like small telephoto lenses. And the first weird thing about them is that they have 2 large lenses.
And so what that does is it takes the image that first lens focuses down the tube, and it blows it up onto the underlying retinas.
But it gets weirder.
Underneath that lens system is a retina, but it's not a sheet of cells, it's layers of cells, and parts of the field of view of that retina have 4 sets of cells stacked on top of each other. And that does a bunch of things for them. One, it allows them color vision because the cells in different layers are typically sensitive to different wavelengths or colors of light.
Retina stacking also gives them sharper vision. Lenses naturally focus different wavelengths of light at different depths, which can blur color vision. This is called chromatic aberration. But the jumping spider's stacked retinal layers align each type of light, like UV or green light, exactly where it comes into focus. Because of this unusual structure, these spiders likely only need 1 eye for depth perception.
And the way they do that is by comparing how in focus something is in the bottom 2 tiers of the retina. Because objects at different distances will be more in focus in one of those tiers than in the other, they can use the difference in focus to evaluate how far away something is. It's something called depth via defocus.
They are not without their own challenges. A telephoto lens is great for sharpness and seeing at a distance, but they have a very narrow and fixed field of view, and the spiders can't move their eyes around like we can. They compensate for this partly by moving their bodies around to get a better look at something, but they also do something else extremely weird and cool. They can move their retinas. This spider is so transparent that you can actually see it happening.
They are able to move the retina around inside the head, swung on that long tube, which is flexible, powered by 6 muscles attached to the back of the retina and then to the body, and it allows them to swing it left and right and up and down, and of course at angles, but also it allows them to twist it for reasons that we don't fully understand yet, but that might allow them some additional visual capabilities.
So it's not their whole eye that moves like ours do, but rather the parts within the eye.
They're all really cool solves, like engineering solves in a certain way.
They use their little legs to keep their eyeballs clean. With these eyes all combined, over the course of evolution, these spiders became elite predators, and the need to spin a web to catch prey disappeared. An ambush predator with incredible vision doesn't need a passive trap, but hunting with their eyes added some increased pressure. They had to start making decisions. They had to choose which prey is worth the energy, decide when to strike, and plan how to approach. So in this new world, the spiders needed the computing power to make that possible. An intelligent spider was born.